Hello, it's your dev dog here. Ruff. There was this one effect that I really liked, and it was this fast travel sequence. What I have here is what we're going to do today. So we have an empty scene, but then we have a pile of rubble. And if we get close to it, you'll see that, it rebuilds itself. And then if we leave, it sort of collapses. I just created an empty. And then inside of this empty, let's go ahead and make our boxes. So we have cube, and then let's duplicate it, and let's do -4 on this one. We're going to just duplicate these again. And then here is our door. Shift click all of them and then add a rigid body onto them. The very first thing that we want to do, here, let's go ahead and delete this update. We're going to get the child count of our transform, and we could just literally just get the child count. Let's go ahead and make each of our variables that we want to hold both of our initial positions. Then we have a quaternion, which will hold our initial rotations. And then we also want to hold rigid bodies inside of an array, which holds all of our rigid bodies. We can initialize them inside of the start. So inside of our initial positions, we're going to create this into a new vector3 array of child count. And we can do the same thing for the other two arrays. We can just go ahead and make a really simple for loop. And we're just going to set this to 0, going to iterate until we're below child count, and then we're going to iterate once through. Let's go inside of initial position. So for each child inside of our transform, we can go ahead and get the transform child by getting transform dot get child, and we're just going to be looking at the I position, and then get the position of the child, then get the rotation dot rotation, and then we're also going to be getting the rigid body, as we want to destroy the door. Let's go ahead and spread that out into its own method, destroy door. So we're just going to make another int, another for loop. And instead of iterating through all of our children and trying to get everything, we can just go through all of our rigid bodies, get the length of it. And once again, we're just going to iterate by 1. And then we're going to get the rigid body, and we're going to set that to rigid bodies. We just get rigid dot is kinematic is equal to false. As well as doing that, we also want to apply a force onto our rigid body. All we have to do is we have to serialize this field so we can access it in the inspector, and then set this as a float and get our random force. We can do random dot range, and then we're going to do negative random force. And we're going to do positive random force. And we're going to do that 3 times in order to get the random force for the X, the Y, and the Z positions. So we want to add force mode impulse. We can just go ahead and call destroy door. If we go back, you'll see that we don't have any way to track how close the player is. And you can add any type of collider that you want. I'm just going to add a borosphere collider, I think, and we'll make this however big we want our range to be. And then once we have that set, we also want to set this to a trigger. All we have to do is call the method private void on trigger enter. We're going to do if other dot compare tag, holding this inside of a const string, and then we'll say player tag, and then we'll set this to player. So we can do player tag. So we'll write for, and then we're going to get I is equal to 0. See, we're using a lot of for loops. We're doing I less than rigid bodies dot length, and then we're iterating through them just one at a time. Rebuild each door piece. We're going to want the rigid body through them, so we're going to get rigid body I, and then we also want to get in our initial position. So if we just look at initial positions, and then we go through I, and then we also want our initial rotations, and then we want to put that inside of I as well. We're going to do a private void of rebuild each piece, door piece. One is going to be the rigid body, rigid. Another one is going to be our vector3 of our position. This is going to be our end position. And then another one is going to be a quaternion. This is going to be our end rotation. We're just going to name this I enumerator. So the first thing that we want to do is we want to track the amount of time that has elapsed. So right now, elapse is going to be equal to 0. We also want to get our rigid transform form. You just go to rigid, and then you just get the transform. We're going to keep track of our start position, be using our rigid transform dot position. And then we also want to keep track of our start rotation. And that's going to be rigid transform dot rotation. We're just going to do rigid dot is kinematic, and we're going to set this to true. What is our duration? Like, how long do we actually want this to run? And now we have to provide that duration inside of here. We can add a serialized field for a private float, and then we can set this as rebuild duration. But we also want a serialized field for another private float, which is going to be our rebuild duration offset. Just one F. So we're going to get our random duration. We're going to equal that to our rebuild duration plus our random dot range. And we're actually going to set this as 0 in the beginning. I think this is simpler to just have the offset be an additive value. And now we have our random duration, and we can pass this inside of our coroutine. And you can see that this is still throwing an error, and we'll get back to that. We're going to write another loop, and this is going to be a while loop. And while our elapsed time is less than our duration, then we want to continue to go through our loop. We want to get the elapsed time and then just add time.delta time. So in order to get our completion value, this is going to be equal to our elapsed time divided by our duration. All we have to do is get the rigid transform and then get the position. We just do vector3 dot lerp, and then our start position, our end position, and then our completion value. Instead of doing lerp, I think slurp is actually a better calculation interpolation method for this. And we basically want to do the same thing with our rotation. Rigid.transform.rotation is equal to a quaternion dot lerp. And then we get our start rotation, and then our end rotation, and then our completion value. So we're going to get our rigid transform, and then we're going to get the position, and we're going to set this as our end position. And we're going to do the same thing for our end rotation. A yield return inside of here. Yield return null. We have to add this coroutine inside of another method as an argument, and that method is called start coroutine. And then we just add the comma at the end, and that's it. If we enter this, should it be working? The reason why it's not working is because we forgot to put on the door summon, and we want to add a random force in the beginning, something like 5.4 and 1. But if we exit, or it's not destroying itself, so we're going to do private void on trigger exit. And we're still going to check if this is the player, because we only want the player to be the one to be able to interact. Is just call the destroy door method.
The Unity engine is fighting against two separate forces that are trying to move each individual rigid body. And you'll notice when we get close that if we start to do it until after, we have those some are still moving up, some are still moving down, and then we have this jitter because we have two different forces being applied to each individual piece. We just call the method stop all coroutines when we first destroy our door, but you will still notice that there is a slight amount of jitter on the boxes. So whenever we destroy our rigid body over here, we set our rigid, and then we set interpolate to rigid body interpolation dot interpolate. But over here, we don't want it to do that. We just set the interpolation mode to none. We should now see that all of our issues are fixed. We go back in, and everything lines up perfectly. This video goes through all of the code without any explanation. If you thought it was too short or you didn't understand what was going on, I have a longer video going through literally explaining every piece of code, why I'm doing it, and explaining stuff about the Unity engine. This is a lot longer of a video, but it is more in depth and explains basically everything. And it even shows the beginning of how I thought about the process of writing the door summon script. That is explained over on the other video. But if you enjoyed this video and you got what you wanted, leave a thumbs up. So if you want to see a part 2 just talking about different ideas and how you might want to see this being improved, let me know. But for now, this has been your dev dog signing out. Riff.